In the vast darkness of space, there's a pale blue dot, wrapped in a veil of clouds, glowing softly with the light of distant stars. From billions of kilometers away, it shines like a sapphire, alone. Our Earth is covered in water. Oceans stretch across more than 70% of its surface. Rivers carve through valleys, clouds swirl in endless cycles, and deep beneath the crust, more water hides, locked inside minerals. We drink it, we breathe it, we are made of it. And yet, as far as we know, no other planet is like this. Nowhere. Not in our solar system, not even in the farthest corners of our telescopes, have we seen a world so drenched in liquid water. Which brings us to a question. Why is the water only on Earth? I'm Juliet, and you're watching Juliet Science. Today we're diving deep into the history of Earth across the cosmic void and into the minds of planetary scientists to explore why water seems so loyal to Earth and whether it might be more common than we ever imagined. To begin, we need to go back to when there were no oceans, no clouds, no rain. Because Earth, despite how it looks now, started out very differently. The dry birth of a blue planet. In its earliest days, Earth was not a blue marble. It was violent, hot, chaotic. Around 4.6 billion years ago, the solar system was just a swirling disk of gas and dust around a newborn sun. Inside that disk, particles collided, clumped and grew, from grains to rocks to protoplanets. Earth was one of them. And in those early days, Earth was dry. Yes, dry. Despite the oceans we see today, our planet formed inside what astronomers call the frost line. That's the boundary in the young solar system where it was cold enough for things like water to condense into ice. Earth formed inside that line, where it was too hot for water to stick around. It vaporized before it could settle. That means at the start, Earth had no oceans, no clouds, no surface water, just heat and rock. So, where did it all come from? One theory points skyward, toward the asteroid belt, specifically carbonaceous chondrites, ancient meteorites containing water-bearing minerals. And here's the twist. These asteroids have a deuterium to hydrogen ratio that matches Earth's oceans almost exactly, like a cosmic fingerprint. During a chaotic period called the Late Heavy Bombardment, roughly 4.1 to 3.8 billion years ago, Earth, along with the Moon, was hammered by leftover planetary debris. These impacts may have delivered water, enough to fill the oceans many times over. But there's a catch. Not all space rocks match Earth's water. Some, like comets, have very different DH ratios. And while comets carry a lot of ice, their chemistry doesn't quite line up. That's led some scientists to think comets may have added only a small portion of our water, if any at all. Which brings us to a different idea. Maybe the water didn't come from the sky. Maybe it was already here. So, maybe the water didn't come from comets or asteroids. Maybe it was already part of Earth, baked into its very foundation. Recent research suggests that water might have been trapped inside the planet's building blocks from the very beginning, bound within silicate minerals, hidden deep in the mantle, waiting. As early Earth cooled, its molten interior began to solidify. Volcanic gases escaped, hydrogen, oxygen, carbon dioxide, and some of that hydrogen met oxygen in the atmosphere, forming water vapor. That vapor condensed, it rained, and over time, the rain pooled, slowly collecting into oceans, and it happened fast. Some estimates say liquid water appeared just 200 million years after Earth formed. That's staggeringly quick, a blink in cosmic terms. Even in a turbulent, dangerous solar system, water found a foothold here, and it stayed. But again, the question remains, why? Why did Earth keep its water, while our neighbors, Venus and Mars, lost theirs? What made Earth the lucky one? To answer that, we need to look outward, because the story of water on Earth is only half the story. The other half is told in the silence of Mars and the heat of Venus. All three, Earth, Venus, Mars, may have started with water, but only one still has oceans. Let's begin with Mars. When Mars was young, it was warmer, wetter. The surface still carries the scars, dried up rivers, lake beds, even what looks like ancient shorelines. Mars probably had a thicker atmosphere back then, enough pressure to keep water in liquid form. But that didn't last. Mars cooled. It lost its magnetic field, the invisible shield that protects a planet's atmosphere from being stripped away by solar wind. Without that protection, Mars's atmosphere thinned. Temperatures dropped. Liquid water vanished, either frozen beneath the surface or lost to space. Today, Mars is a cold, dry desert. But its past tells us something important. Liquid water is fragile. It doesn't take much to lose it. Now let's look at Venus. Venus is almost Earth's twin. Similar size, similar mass, and not far away. But it's also a lesson in how things can go very, very wrong. If Venus ever had oceans, they're long gone. Here's what likely happened. As the sun slowly brightened over time, Venus heated up. Water began to evaporate, and water vapor, as it turns out, is a powerful greenhouse gas. More vapor meant more heat. More heat meant more evaporation. A runaway loop. Eventually, Venus got hot enough to boil its oceans, if they ever existed at all. With no magnetic field to protect it, solar radiation split the water molecules, the hydrogen escaped into space, and the planet was left dry. Today, Venus is a furnace. Surface temperatures over 470 degrees Celsius, an atmosphere of carbon dioxide, crushing pressure, no sign of liquid water. Mars froze. Venus burned. Earth held on. It comes down to one word: balance. Earth has just the right mass to hold a stable atmosphere, not too thin like Mars, not too thick like Venus. We sit at just the right distance from the sun. Not too hot, not too cold. And we have something else. A magnetic field, powered by our molten iron core that shields our atmosphere from solar radiation. But there's one more piece of the puzzle: the moon. Unlike any other planet in our solar system, Earth has a massive moon for its size. And that moon does something crucial. It stabilizes our axial tilt. Without it, Earth would wobble wildly, swinging between extreme ice ages and brutal heat waves. But with the moon, the climate stays steady. Oceans stay liquid. Life gets a chance to thrive. All of these things together, mass, orbit, magnetism, the moon, make Earth an oasis. Not just a place where water can exist, but a place where it can stay. Still, this leads us to an even bigger question. If Earth's success depends on so many perfect conditions, how rare are those conditions in the universe? Are we a cosmic fluke? Or are there others like us waiting to be discovered? To answer that, we'll need to go even further. Beyond Mars, beyond Venus, beyond our sun. We need to search for oceans among the stars. For most of human history, the stars were untouchable. Points of light, unmoving, unreachable, unknowable. But that's changed. With telescopes like Kepler and James Webb, we've started pulling back the curtain on the cosmos. And what we've found is staggering. Planets are everywhere. More planets than stars, in fact. Billions, just in our galaxy. They come in all shapes and sizes. Some orbit red dwarfs, others giant suns. Some are scorched and airless. Others are buried in ice and clouds. But among this chaos, one particular class of worlds is capturing our imagination: ocean worlds. These are planets rich in volatiles, especially water. Some are super-Earths, larger than our planet, but still rocky. Others are mini-Neptunes cloaked in thick atmospheres with oceans hiding below. And then, here's the twist. Water is common in the universe, It's found in molecular clouds, in forming planetary disks, in comets, moons, and even the atmospheres of distant exoplanets. In fact, some of Jupiter's moons, like Europa and Ganymede, may hold more water than Earth, locked beneath their frozen crusts. So the question isn't, is water out there? It is. The question is, why haven't we found another planet with oceans on its surface? Part of the answer is simple: technology. Even with our best telescopes, directly seeing an Earth-like planet is incredibly hard. They're small, dim, lost in the blinding light of their stars. Most of what we know comes from indirect clues, the tiniest dip in starlight, a subtle chemical fingerprint. Detecting water on a world hundreds of light years away? That's not just science, that's precision. In 2019, using the Hubble Space Telescope, scientists detected water vapor in the atmosphere of a super-Earth called K2-18b. It's about 124 light-years away, bigger than Earth, wrapped in a thick hydrogen atmosphere. And in that atmosphere, the unmistakable spectral signature of water. It was a breakthrough. The first strong evidence of water in the skies of a potentially habitable exoplanet. But K2-18b isn't Earth. Its conditions might be far too extreme for life as we know it. And just because there's vapor doesn't mean there's an ocean below. Many of these alien worlds might be smothered in clouds, or buried in crushing pressure, or locked in deep freezes we can't yet pierce, which raises a strange possibility. Maybe Earth isn't the only water world. Maybe it's just the only one that shows it. Because on Earth, water is bold. It sparkles. It crashes. It falls from the sky and flows in rivers. It shapes coastlines and stirs clouds. But on other planets, water might be hidden, locked beneath ice, trapped under high-pressure layers, or buried so deep beneath alien skies that we'll never see it. Not with light, not with telescopes, not even with hope. Our atmosphere, magnetic field, volcanic cycles, stable orbit, they all act like gears in a delicate machine. Together, they regulate the climate. They keep pressure high enough. They keep water flowing. Venus, on the other hand, kept its atmosphere just fine, but it trapped too much heat. It became a pressure cooker. Earth somehow hit the sweet spot. But that success? It's not guaranteed. In fact, it's terrifyingly fragile. One wobble in orbit, one shift in volcanic activity, one change in magnetic shielding, and Earth's oceans might never have formed, or never have lasted. And yet, not only did they form, they became the defining feature of this planet. No other world, not in our system, not beyond, can say the same. So maybe Earth isn't the only water world. Maybe it's just the only one that puts its oceans on display. Other worlds may hide theirs, under kilometers of ice, beneath clouds we can't see through, or in chemical forms we don't yet recognize.